Warm up number 26, power standards 3 and 4. Power standard number 3. We need to graph these equations. So if I look here, this is written in slope-intercept form. Pretty close to slope-intercept form. I want to change my minus here to plus, so I keep change, and make that a negative 8. So that means that my y-intercept is at negative 8. So I go to my y-axis at negative 8 and put a dot. Then we apply our slope. Our slope is the coefficient of x. When we graph, remember it as rise over run. So we have 5 over 7. So from this point, I'm going to rise 5 and run 7, both in the positive direction. And I could do it again, but I'm going to run off the graph. So I'm just going to be careful to draw a nice line through both of these points using a straight edge. Then looking at y equals negative 4, our next equation. Again, remember, we want the value of y to always be 4. So x is vertical, y is horizontal. So on our y-axis, I come to negative 4, and I'm going to draw a horizontal line through that point. Because through this line, your y value is always going to be negative 4. And what we can see is that the lines intersect. So, how many solutions does a system of equations have? 1. Explain our answer. We're going to say the graphs intersect at one point. Power standard number 4. Are these shapes congruent? Keeping in mind, congruent is the geometry word for equal. So are these shapes equal?